In this case, you have a person O standing at a fixed reference frame, and you have a person on the boat at point A. Point A is at translating frame because it's moving with translational motion, where you have the X, Y, Z refer to the fixed reference frame, and X prime, Y prime, and Z prime refer to the translating frame. You want to know the velocity of the dart here, which is labeled by B. If you measure the displacement for the point B with respect to point O, then this displacement is known as absolute displacement. On the other hand, if you measure the point B with respect to A here, then this displacement is called the relative displacement of point B with respect to point A. By using the head-to-tail method, RA plus RB/A is equal to RB. Then your RB/A is equal to RB minus with RA. So this is your relative displacement. You can find the relative velocity by taking the differentiation. So take the differentiation of the displacement with respect to time, then you obtain this result. And take the differentiation of velocity with respect to time again, then you obtain the relative acceleration. Let's try with this example. In this case, you have a point O, which is a fixed reference frame, and you have a point A, which is moving in curvilinear line, and then you have a point B, which is moving in linear motion. At this particular instant, the object A is traveling along the circular path here, and the speed is increasing at 10 meters per second squared. So you obtain the acceleration at point A to be 10 meters per second squared. Object B is traveling along the straight path, and its speed is decreasing at 5 meters per second squared. Therefore, you can obtain the acceleration for point B is equal to 5 meters per second squared. Direction for the acceleration is opposite to the movement of point B. This is because object B is experiencing deceleration, where the speed is decreasing over time. And you need to find the relative velocity as well as the relative acceleration of object A with respect to B. Since B is moving in a linear path, therefore B is translating frame, and we are performing the relative motion with translating frame. First of all, let's find the velocity of object A with respect to B by using this equation. VA/B is equal to VA minus VB. VA and VB are absolute value, and they must be measured with respect to inertial point. So let's choose point O here to be our inertial point, and you are going to measure VB with respect to O and VA with respect to O here. In this case, we assume moving up to be positive Y direction, and moving to right is the positive X direction. Since the object B is moving to the left hand side in the negative I direction, multiply the direction with the magnitude, then you obtain the vector of VB, which is equal to negative 8I. Object A is experiencing curvilinear motion, therefore the velocity that we obtain is called the tangential velocity. It's moving in a positive J direction. Multiply the direction with the magnitude, then you obtain the vector VA to be 4J. Substitute the VA and VB into the original formula here. 4J minus negative 8I gives you 8I plus 4J. So this is the relative velocity A with respect to B. You can find the magnitude by using this formula, and you should get this answer. We can find the acceleration of A with respect to B by using this formula. Previously, we successfully obtained the velocity vector for point A, which is 4J, and velocity vector for point B, which is negative 8I. And from the question, we obtained the acceleration at point B in the positive I direction, therefore AB is equal to 5I. On the other hand, the acceleration for the object A is equal to 10 in the y direction, therefore the vector is 10z. We can easily find the acceleration B to be 5i. For object A here, since it is doing the curvilinear motion, therefore it will experience acceleration in terms of tangential acceleration and normal acceleration. So for the tangential acceleration, we obtain 10z, and for the normal acceleration, which is pointing toward the center, we can compute the normal acceleration by using the tangential velocity square divided by the radius. Therefore, we can form the acceleration at object A to be 4 squared over 0.5 in the I direction, which is here, and then you need to add up with 10z, which is this direction. So this is the AT component, and this is the AN component. Substitute phi I into this formula and substitute the acceleration at object A into this formula, then you can compute the relative acceleration to be this answer, and you can proceed to find the magnitude to be this answer.